Hello, welcome to the video. My name is Bob Bailey. Remember to practice sound safety practices at all times. So let's get started. The first thing to do is to become thoroughly familiar with the kit. Study every part. You may find it helpful to keep a journal as you construct the engine. If you don't have a surface plate, you can use the table of your milling machine as a substitute. Need some type of measuring device. A machinist square comes in real handy. And you need something for shim stock. I like to use tool bits, and I take a feeler gauge apart, and I bought a couple of cheap ones, and they help out a lot. Also, you need layout fluid. Don't forget that. Paint the surfaces that are going to be machined. And take note of the operations that will be performed on the casting. Measure and record the diameter of the hub and measure the height to the top of the hub. These two figures are used to derive the center of the crankshaft, and that becomes your reference. So scribe the center line for the crankshaft and scribe the center line for the pivot using the drawing as a reference, and now scribe the finish line at the bottom and at the top of the casting. After doing this, now we're going to lay the casting on its side. I used a V-block for a shim here. Make sure that it's square. Now we're going to repeat basically the same procedure. We'll measure the height to the top of the crankshaft boss. Calculate down to the center line. Now we have the center line for the pivot and the crankshaft, because they should both be the same. Now we're ready to set it up on the milling machine. I use the standard Sherline hold-down clamps, the surface gauge. I have used the tool bits and the feeler gauge pieces to make sure that this is reasonably level. We also use the wiggler. For those of you that are not familiar with it, this is what it looks like. There's 4 different tips that come with it. We'll be using the point tip and the tip in front, which holds the dial indicator. There's also a ball tip and a disc. We won't be using those in this video. They're explained in the instructions that come with the wiggler. One thing to remember about the wiggler is never ever try to center it with your hands. It can be a real deadly weapon. Just watch what happens here. Alright, now after you've got the casting tightened down on the table, double check to make sure that you're tracking in the y-axis on the center, on the line, the bottom finish line, and then very carefully use a magnifying glass if you have to, center on the crankshaft hole in the X and the Y axis as close as you can. Now let's get started drilling with the center drill. Just let the center drill kiss the casting Don't try to drill the starting hole yet. Just barely touch it. Back off. Take the magnifying glass and make sure you're on the center line. Both directions. Make any necessary adjustments. You may be a thousandth or two out, so you want to get it as close as you can. Now come down, try it one more time, a little deeper this time, and check again. Once you're satisfied that you're in the right spot, then go ahead and get your hole started. Now we can change over to the drill size specified in the drawings, and using your favorite cutting fluid, we'll drill the hole. If you're a beginner on the lathe and the mill, you may have surmised at this point that this is not a beginner's video. We've assumed that you have a basic knowledge of lathe and milling machine operation. And if you don't have that, you may want to take a look at our other videos on basic metal milling machine and basic metal lathe operation. Or get yourself one of several good books on the subject and make some practice projects, simple projects. Not this is a first engine project, not a first project. Alright, now we'll ream the hole. Be sure and slow the mill down to the appropriate speed. Use some more of our cutting fluid. Now that you've got the crankshaft hole located, we're going to drill the pivot hole. And remember, I said the crankshaft hole is a reference. So we use the dial on the lead screw and move up to the pivot hole. Double check to make sure you're in the right spot, but you should use the dial and move what the drawing shows. This model can be built on standard size machines. However, the Shoreline equipment is ideal for a model like this. Remember, safety first, safety first. Now we're ready for the two ends. Whenever possible, I like to use a 3/8 end mill because it's stiffer than the smaller mills. And if there's not any interference with anything, there's no reason not to. I'll start on the base. And don't take the whole thing at one time. There's casting draft on the base and on the top, and you can see here that the bottom of the casting is not vertical in this position. So come down halfway or so on the casting and work your way into the line, the finish line. After you've brought it into the finish line and without changing that setting, now go back and get the lower part of the casting. Now we have two flat, smooth surfaces on the feet of the casting. What looks like a defect in the video is actually just cutting fluid that's coming down on that. The bottom is flat. Now do the same thing with the top, only on the top you can take the whole thing in one, that is in the z-axis. You can take the whole thing in one cut. You probably want to run through this video several times before you get started. Now we're going to do the face of the casting. Bring this surface down to the dimensions shown in the drawing. And then once you've reached that dimension, lock the z-axis down so you don't move any lower. Actually, it's a good idea to lock the z-axis on every cut, just to be sure. Nothing worse than having a cut that isn't to the same uniform depth all over, especially when you're at your final cut. We try to keep the setups as simple as possible. You've heard of the KISS method. Steve calls it the Keep It Simple Steve method. Wherever possible, we use common tools that are found in most shops. Now that you've reached that level without changing the z-axis, move down and get the crankshaft hub and the 2 feet. Okay, now we're ready to drill some more holes in the base casting. For this, we've converted the Shoreline over to horizontal mode. It's a lot easier with a casting this tall to do it this way. We're going to use our wiggler again to center on the holes, having marked up the casting again using layout fluid and marked the 2 exhaust passages, or exhaust and inlet tank passages, and the ports and the base holes. We'll use a dial indicator to zero in the head of the mill. I like to do this whenever we change from vertical to horizontal or back. Only we're using an antique dial indicator. I thought it might be kind of nice to see what our grandfathers used. You have to adjust it so you zero it in. And I use the edge of the spindle housing. It seems to be pretty accurate in relation to the spindle. I've tried it both ways and that works well. Alright, now we're getting ready to drill the holes for the two steam passages. And we're going to use the center drill again. Same operation. Zero in on those holes. Only this time we're going to use two different drills. This is drilled with a larger drill for the threaded portion of the hole. Now be careful not to drill too deep on these holes, because if you go all the way through on this casting, you have a problem. So drill to the depth indicated on the drawing. After we drill those, then we switch to the larger drill, and we drill into the depth indicated for that drill. Now we're ready to drill the holes in the base. This is a lot easier when you're in horizontal mode. The hole on the other side is the same. We don't show every hole to drill. Now we mount the casting in a vertical position to drill the ports. Notice we're using 3 blank tool bits, and we're using a piece of key stock in the slot on the table, and the casting is pushed up against that key stock, so it's it provides a nice reference to make sure that it's parallel to the x-axis. We use our wiggler again. Center on the 4. We're going to drill 4 exhaust port holes. And we've scribed lines in accordance with the drawing. Drawing is your reference for everything, the Bible for everything. Okay, now unfortunately we have made a mistake here and drilled that first center drill hole off. So we have another hole that's on the same axis. So we move over to that hole, and we've center drilled on that and drilled it. And now that we're at the right height, we'll move back to the hole that we've made the mistake on, and we'll drill it in the correct spot. Otherwise it's a little difficult once you've made a mistake like that to drill to find the right spot. Next we're going to move over to the lathe. First thing we're going to do is the piston rod. We're going to thread the end of it. And the Sherline uses a different approach to threading, and when I first saw it I was a little bit taken aback by it, but after having used it I found that it works very well, and it's very easy to do precise work with it. We're going to use a center gauge here to make sure that the threading bit is perpendicular to the axis. There's a notch in the side if you're not familiar with it. And we've selected the correct gears for the thread that we're making, and we begin our cut. Follow the manufacturer's instructions on this. They know what they're talking about. One thing I do like is it's so easy to stop at the exact point you want to. If you've done threading on other lathes, you know what I'm talking about. Now, before you go too far, it's a good idea to use that center gauge again and check the pitch to make sure you're getting the right number of threads per inch. Once in a while somebody will select the wrong gear and it's not exactly right, and then you cut the piece and you're beyond the point of no return and you have to start over. It's a good idea to use something to test the thread while you still got it mounted on the lathe. Next we're gonna do the piston, and some machinists prefer to do the piston after they've bored the cylinder, and there's merit in doing it that way, because if you overbore the cylinder you can make the piston a little larger. But the way this video is put together, we're doing the piston first. You face it off and center drill it so you can drill your hole. The piston rod is peened to the piston, so you have to drill the hole as they indicated in the drawings. Now we ground a special bit for cutting the piston ring grooves, and you can tell from, you've got a side profile of the bit here, and you can see that what you need to do, and you need to make it the thickness required to cut the groove. And you may want to try a little trial and error on a piece of scrap to make sure you're getting the groove the right distance before you cut the piston. We'll cut 2 grooves. We don't show all the machining in every operation, because if we did, this tape would be a lot longer, and you could use it as a cure for insomnia. Alright, we've cut the grooves. Now we're going to use the cutoff tool to cut the piston off of the rod, and we use the caliper to set the cutoff tool down to the correct distance, and we begin our cutoff operation. Never hurts to measure twice. Here again, we're going to need, when using the cutoff blade, you need to use an adequate supply of cutting fluid. And you can catch the part so it doesn't fall on the floor and roll under the bench, and nick itself up. And our next item is the connector for the other end of the piston rod. We're using the 4-jaw chuck here, and we've center punched the line that we scribed on the surface plate with it, and we're using the wiggler in the center punch, and we're zeroing it using the dial indicator. Now here we don't really need to get closer than a thousandth or so. You can waste an awful lot of time trying to get something to be centered perfectly, and you're in a situation where it doesn't make any difference. So we'll bring it down to within a thousandth or so, and that's perfectly adequate for this part. old saying, never use more precision than is needed for the operation. Okay, now that we've accomplished that, we're ready for a hole. Oops, I'm sorry. We're going to face it off first. I'd forgotten. Face it off and then we'll drill our hole. Face it off to length. Center drill it. Now here we don't need to ream it because we're going to tap threads in that. Drill it to the correct depth. Now we're ready to tap it. We use the live center to bring a little pressure on the tap, and we take up the slack as the tap threads itself into the hole. But don't put too much pressure. Taps like to break, and they're not fun to take out of a hole. Okay, here's our piston. And we're going to peen it on the end of the piston rod. Got the piston rod mounted in a vise with something wrapped around it so that we don't scratch it. Just peen it lightly. The idea is not to use a sledgehammer here. Now, of course, we'll use a locking nut on that, but we're not ready for that until we assemble the engine. Next, we're going to move on to the cylinder casting. And we're going to use a dial indicator to center it. As it's going to be a rough centering because we're on a casting here, a cast surface. But measure both ends of that casting on the outside and the inside diameter, and make sure that you select the end that is most nearly in the center. And then once you've got it centered, using the dial indicator as close as you can, we're ready to start. We'll begin by facing off the first end of the cylinder. Now don't take it down to length at this point. Just take it down to approximately half of what you're going to have to take off. Otherwise, the appearance of the cylinder won't be right, and it's going to be difficult to bore the holes and make a fitting on the other end. So now also it might be a good idea when you're doing this, if you have the piston, to use it as a gauge. Clean out the bore and check it. Of course, you could do it the other way around too. You can make the piston to fit the cylinder if you made the cylinder, if you bored the cylinder first. One thing that, or another thing you might also consider is that you do this when you're about ready to turn out the lights and quit for the day, and don't make your last cut or two and allow the cylinder to cool off, because it gets pretty warm when you're doing this operation, and aluminum has a tendency to expand, and after you've taken it out of the lathe, it's difficult to get it back in exactly where it was. It can be done, it's just a tedious job to do it, or it can be done close enough for our purposes. You let it cool off and then measure the bore, and I use telescoping gauges for that, incidentally. Measure the bore and then do your finish cuts. Okay, now that we've got one end faced and the bore done, we're ready to go back to the milling machine. And use the surface gauge to ensure that the casting is flat on the surface there, and then using the bore as a reference, use the dimensions in the drawing and mill off that face. Don't do it all at one time, and again, remember to lock the Z-axis before you start. Each time you move it down, lock it. I believe the instructions say to use a fine emery paper on this to finish it off. Once you get it down, put it on a flat, hard surface, the emery paper, and work the machining marks out of that surface, and also do the same on the base casting. So we want that to be a good seal on there, a good mate. Now stop fairly often and measure this so you know where you are. You don't want to go too far on this one. There's times when it doesn't matter, and there's times when it does. And this is one of those times where you could have to order a new casting. They are available, by the way. That's one thing about this this kit, is that it's reasonably priced, and if you mess up a casting, a replacement part is available. Alright, now we're ready to do the other end of the casting. And as you can see, we made a homemade arbor. The theory is when you tighten the screw, the arbor spreads apart and locks the casting on there. No super secret there, but it's nice to have one that exactly fits the job you're doing it. So we mount that on the chuck, and we face it down. Now we face it down to length. So doing it this way, we should have two ends that are parallel to each other. That's the goal anyway. One thing I found with these PM Research castings is that they're good castings. The quality of the kit is excellent, in my humble opinion. One thing I would suggest if you're fairly new to the hobby is make several of these. Make them until it's almost second nature, the steps that you do, because the same approach that we're using on this pretty well applies to any project. And you learn this discipline, you'll find it a lot easier to approach projects that you might have been a little intimidated by, and you'll be spending a lot more time in your shop and producing a lot of things. Plus, these make nice gifts. It's a wonderful gift for a grandchild who might get interested in the hobby himself. Now, after you've made a couple and you feel really good about it, then I'd order the brass castings. This is available in aluminum and brass, and it really makes a beautiful model when you make this out of brass. Okay, we've marked up that surface again. Now we're going to have to drill the pivot hole and thread it, and we're going to have to drill the two ports in the cylinder casting. So we have a nice flat surface there, so we can just measure up from that and mark off the points. Now we're going to mount it in a V-block, and we use the machinist square to make sure that we've got that surface perpendicular to the surface plate. And then we use the arbor itself as a reference here. Now we come down from that to the center line and scribe it, and we should have a center line for the two ports and for the pivot point, all the same. Okay, we're back to the mill, and we're going to use our friendly surface gauge to make sure that that's in there square, just like we did before. And we used a center drill, same. Now this hole doesn't go all the way through, because this is the hole we're going to tap. And it's pretty critical that this hole be in the right spot too. Some of the others we can get away with a little bit, but this one we want it to be pretty close. Okay, drill to the depth indicated on the drawing. Then spot drill the two ports. Spot drill and drill each one. Whenever you're setting up over a hole, generally speaking, it's a good idea to do every operation on that hole before you move to the next hole. Makes life a lot simpler that way. Okay, now we're going to tap that pivot hole, and here's a trick I found with the Shoreline, and this might apply to some other mills, but not all. I loosen the draw bolt so the chuck is loose in the spindle, and I hand turn the tap down, and when I've come down to the end there, then I lower the head again. So that holds that tap nice and straight. You don't get it started crooked. And it works like a charm. Okay, now we're ready to drill the holes in the ends of the casting, of the cylinder casting. So we've moved our vise around, and we're going to zero it in with a dial indicator. We want it to be as close to right on as we can. So don't tighten the mounting screws down too tight. Just kind of snug enough so you can move it around gently. And using the dial indicator, move on the x-axis back and forth, and then tap the side of the vise lightly to make corrections. A lot of times you can mount the vise and not have to do this depending upon what you're doing. But with drilling these holes, we've got to get that vise zeroed in. So this is the way to do it. These dial indicators save an awful lot of time. And probably a lot of rework parts too. Now that we've done that, we mount the casting and we center over the bore. And we can run this so it will turn all the way around without moving the needle. That's the spot we want to be in. Then we use trigonometry to calculate the location of the 4 holes. Incidentally, if there's enough requests for it, I can put some notes up on my website that you can download to get the X and Y coordinates for this and a few other things that might be useful. So my email address is at the end of the tape. If you'd like to see something like that, just send me an email and I can put it up on my website so you can download the page and take a look at it. All right, now set the caliper on 75 or 3/4 of an inch and make sure that your holes are on center there, because we've got to drill 4 more holes in the head of each end and they've got to fit. So we want them all to be in the right spot. We're going to drill and tap these holes. We use the same method for tapping on this that we did on the pivot hole. We loosen the drill taper in the spindle, and that way that tap is held straight and we can turn it in by hand. Alright, here's a finished cylinder alongside a rough casting. Kind of pretty, ain't it? And I believe here we've already lapped the surface down with the emery cloth. So we've got the machine marks out of it. Alright, next we're going to do the top and bottom, or bottom and top cylinder heads. This is the bottom one here. And clean it up first. Get that casting lug off of there. I suppose proper practice dictates that we grind that casting lug off there before we start, but this is such a small part I don't think it really is going to make much difference. we went ahead and did it this way anyway. Now, one thing you want to do when you're facing this off is measure the thickness of it, see how far you've got to go down. And don't forget there's a step in that, so we want to allow for that when we measure the thickness before we take it down all the way. Okay, we've already drilled our hole and reamed it. We're just truing up the outside a little bit. Okay, now we're going to do the top head, and the thing we're going to show you here is just how we lined it up in the lathe. Some people have asked how you do this piece, because there's not a real lot to hold on to here. We use a 3-jaw chuck, which works fine for this. We've used a 3-jaw chuck mostly in this, and it's plenty accurate for what we need. Haven't had any problems. And now we use the dial indicator after we've lined it up by eye to see that that's running in there as true as we can make it. Of course, the rough surface is not going to zero in exactly, but you can see that it's running straight. Once we've finished facing it off, we're going to move over to the mill and drill the holes for the cylinder head. Now we do this with the rotary table, and we want to zero this in again as well as we can. We mount the 3-jaw chuck from the lathe on the rotary table, and it's a simple job to set it to the radius. Once again, we want to make sure we're drilling the holes in the right spot. Okay, now we're ready for our flywheel. And you notice we're using a 3-jaw chuck on this. It's a tribute to the quality of the castings. Quite often you'll get a flywheel and you'll have to use the 4-jaw chuck to center it. Now, when you're centering this flywheel, you want to do it on the inside rim, not the outside rim, the inside rim of the casting. And in this case, it was just kind of checking to make sure it was okay, because we didn't have to do anything. But if you center on the outside rim and your inside rim happens to be out, that flywheel is never going to be balanced correctly unless you do a lot of hole drilling in it. So we measure the inside rim, and then we indicate the face to make sure we've got it running true in the chuck, because we don't want to wobble in it. I hate to go to a model show and see flywheels that wobble, or the inside rim is going around like a hula hoop. You know, whoever did that did not center the inside rim. So that's one thing you always need to remember when you're doing a flywheel, is to check the inside rim. And the drawings on this case just call for to turn and clean up the casting. They didn't give any specific dimensions, so you don't want to take any more than is necessary off of it, but just where you have a nice clean looking flywheel. So we do the face and we do the rim, and then we turn the flywheel around. As I said earlier, you might want to make a journal and make an entry for every part you do, and also, you know, what tools, what drills, what taps are required for each part. And if you're doing it on a combination machine with a mill and a lathe all in one, you might be a good idea to separate all your lathe work and all your mill work that you can do, and do one and then the other, so you don't have to change over from lathe to mill and back to lathe again any more than necessary. And same way with the vise, on the machinist vise on the mill. Try to coordinate jobs so that you can take advantage of the setups that you have. We've tried to keep these setups as simple as possible, as I said earlier, but that is I think the major point we're trying to make with this tape is to show the setups you use, because they'll be different with every project that you do. Now we're ready to drill the center hole, and we're going to ream it out. And then we'll turn the flywheel around and do the other face. It's a fairly deep hole all the way through, so you want to back out and let the chips clear. And remember to slow the lathe down before you do the reaming. You don't ream at the same speed you drill at. Alright, now we've turned the casting around, and now you want to indicate on the machine surface, which is now the back side of the casting, so that the second surface is parallel to the first surface. Now, since we're just facing it, we don't have to worry about centering it as much as we do making sure that it doesn't wobble. So this is another pretty critical one. We want that running as true as we can in there. Just tap it a little bit before you tighten everything down. Just get it running as true, and then after you've tightened the vise down, check it again. Make sure that you didn't move anything when you were tightening it. Okay, we'll tighten it up and check it again. Now we're ready to face it. Okay, now we just use the machinist vise to hold the flywheel at a right angle. You just want to make sure it clears the rim to drill the hole for the set screw, and then tap it. While we're doing this, we can use the machinist square and the clamp to drill the lube holes in the base casting. We need to drill 2 holes, and they both have to be at an angle. So we'll drill the hole for the crankshaft, and then we'll drill the hole for the pivot. And they're both at 45-degree angle, but they're 90 degrees from each other. One's on one plane and one's on the other. A little clamp comes in handy for things like this. Over the years, I've accumulated quite an array of clamps and V-blocks and things like that here and there, and really makes using the equipment a lot easier. All right, now we're ready for the crankshaft. We're using that 1/4-inch cold roll for this, and I like to face them on the lathe off the length. It gives you a nice appearance. Then you chamfer both ends, and here we're using the Shoreline knurling tool, which is a real easy tool to use and doesn't put a lot of stress on the equipment. Here we have the crank throw casting, crank casting. We need to face that down, and we need to turn it down so it runs fairly straight. Needs to be faced square with the bore, so we're going to do everything in one setup so we ensure that we are square with the bore. Requires an arbor press, excuse me, to put the shaft on the crank casting. That's why we knurled it. But if you don't have an arbor press, you may want to improvise with a hydraulic jack or something, but don't use the spindle on your milling machine to press that in there. Now we're going to face it off. Center drill. Drill it and ream it. This is a press fit, so we don't ream it out to 1/4. And we're ready now for painting and assembly. If you can't get this kit through your dealer, you can get it from PM Research, or you can get it from me.